Hello everyone, I'm Saptarshi Mukherjee. I'm a software engineer 3 at Google and I've been a competitive programmer. So in this playlist we are basically discussing the problems that appeared in Leetcode weekly round 385, and this is the third problem of that contest, most frequent prime. So let us see how we can solve this problem. We are given a matrix, not necessarily a square matrix, it's m cross n, and from any location we can start iterating, and there are 8 paths from the matrix, including the diagonal paths. So these are the 8 directions. It is given that we cannot change direction. It is invalid to change the direction during the move. Return the most frequent prime number greater than 10 out of all the numbers created by traversing the matrix, or -1 if no such prime number exists. If there are multiple prime numbers with the highest frequency, then return the largest among them. Okay. So let us look at this particular example, 119911. So we have 119911. So if I start from here, so if I start from the top left thing, and if I plan to go to the right, I get 11. So 11, yes, it is a prime number. I'll count it. If I go towards the bottom, I get 19 and 191. I get 19 and 191. I believe both are prime numbers. 191 191 should be a prime number, I think. Is it or is it not? Let us search it. 191 is prime or not? Prime or composite? 191 is a prime number. Prime quadruple. That's good. So 191 is also found. From here we will find 11. So 11 we have found twice already. From this one also, if we travel to the left, and from this one if we travel to the left, we find 11. So basically 11 is found 4 times. 9, let us see. 9 we can find here, okay, so it's given that it has to be greater than 10. It has to be greater than 10. A prime number greater than 10. 9 is neither prime nor a number greater than 10. So we will look at the bigger ones. 91 is not a prime number, but 19 is. So 1919. From here, if we go diagonally, we have 1919. This diagonally, we have 1919. And then similarly here, 19191919. So if I look vertically, I should get 1, 2, 3, 4. If I look obliquely, then I should get again 4. So it should be something around 8. And 191 should be 4 times, if I'm not wrong. Similarly, we can have others as well. So 19 in our calculation, it appears 8 times. So one time from top to bottom, another time from bottom to top also we have to calculate. In this way, I think we have around 8 times. So this occurs, I think, the most number of times. 19, the most frequent prime number is 19. Yeah. Similarly, over here, 7, you don't have any other possibility. So 7 is the only number that you can form, and 7 is not greater than 10. Similarly, you could form larger numbers but still remain unable to find anything. For example, let's say 1, 0, or you can't have 0, I think that is given. So let's say we have 1, 2. So 1, 2, if you try to go down, you have 12, that is not a prime number. If you go up, you have 21, that is not a prime number. And only 1 and 2, they are less than 10, so you can't take them. So here also your answer will be -1, that we have no prime number that is greater than 10. Awesome. So now how can we solve the problem? For this, as I've already shared with you before, you should look at the constraints. It's a 6 cross 6 matrix at max. So we basically have at max 6 rows for 6 cross 6. So there are how many starting points? At max there are 36 starting points. There are 36 starting points. From each starting point we can go to 8 directions. And at max in any direction how much can we go? We can go 6 steps, or we can say from there 5 steps. Let us take 6 steps. So we reach up to here. 36 into 8 into 6, that is the maximum. We can take average, that is by 2 also, but let us take this one. What do we get? 36 into 8 into 6. 6 into 8 is somewhat 48, which we can consider as nearly equal to 50. So it will be somewhat around 1800, less than that actually. So in less than 1800 steps it will be done. Why think about any better approach? Just go through this, do the brute force, and it will be done. So this is the only brute force thing among only brute force solution that I am discussing. Um, I'm discussing the 3 problems in this playlist, 2, 3, and 4, and this happens to be straight up brute force. But yes, there is one more thing. You have to find out whether it's a prime number or not. So there is another step over here. You need to calculate whether it's prime number or not. So for each number that you form, let's say up to here, you form a number, you need to check whether it's prime or not. A 6-digit number, how much time do you need to check whether it's prime or not? If it's a 6-digit number, you can say in square root of 10 to the power 6 time whether it's prime or not. So it will be 10 to the power 3, so it's 1800 into 10 power 3, which turns out to be 1.8 into 10 to the power 6. Comfortably you can complete it. So for checking or for finding out all the prime numbers up to 10 to the power 6, that also you can do. If you want to find out, let's say, all prime numbers up to 10 to the power 6, then you can use Sieve of Eratosthenes. Sieve of Eratosthenes. You can store in a hash map and you can then plan better using that. So Sieve of Eratosthenes will basically take something like this, big O n of log n. So it will be something like 10 to the power 6 into log 10 to the power 6, which will be somewhat 10 to the power 7 or slightly greater than that. But should be less than 10 to the power 8. So it will be 10 to the power 6 into log 10 to the power 6. Do you need it over here? No. If you find it individually, you get this. So this is without sieve. So this is without sieve. So what are we doing here? This is basically our is prime. We are checking whether it's prime or not. And if you use sieve, then this is somewhat your initial cost, which is in this case bigger than doing it separately. But if you do this, after this you can just check whether each of the numbers you are forming is there or not. So then it will be this time complexity plus this one. You don't have this multiplier then. You just have this one plus this one, if you follow that way. Otherwise you just follow this one, it will be simply this. That's it. Awesome. So let us look at our solution. This is our is prime code, which will just take a number and say whether it's prime or not. Most frequent prime, we will basically iterate. This is our modularity. This question is good in another way. This actually tests your uh, ability to include modularity in your code, to actually code things which need to be modularized in order to be coded easily. So you learn some of those practices from here. So basically I'm calling this iterate function to iterate in all those directions using this while loop, and from there I'm calling this is prime. So you can see the dependency. In this way my original code or my main code looks quite neat. From there I'm calling this function and simplifying my operation. These are the different directions. So the dx dy indicates that at every step whether I'm moving one step to the left, one step to the top, or that way. So there are 8 possible directions. I've simulated those 8 possible directions in these lines. 0 0 dx dy I'm ignoring. Remaining plus minus I'm just incorporating that. So in this function I'm basically saying, hey, if I ask you to move in dx direction and in dy direction in this way, in x and y direction in this way, then what can you provide me? So for here ij is basically my starting point, n comma m are my boundaries. I'm checking that, hey, as long as you're within these boundaries, keep on going, and whatever numbers you are forming, check whether it's prime or not. So we are counting this for all the numbers possible from this starting position. Yeah. One thing that probably you will notice is that I'm doing this operation for the starting position so many times. So am I counting that single step from the starting position for all the 8 directions? Because this z greater than equal to 10 is a condition, that is why it is not getting overcounted. If it would have also included the single digit prime numbers, this probably would have caused an issue in my code. But because I saw that this greater than equal to 10 is a requirement, so that condition is not creating problems for us. That's it. Finally, I'm checking that, hey, uh, we are storing in this hash map that I've passed from the main function that for any of these numbers which are prime numbers greater than 10, store this. Store this count, whatever is the existing count plus 1. And then later on access this count. Get the count from that hash map, that is your maximum. I mean, so if that count basically exceeds the existing count, or it is equal to the existing count and your current element is greater than the existing maximum. Why did I add this? Because of this line. There is a line given that if there are multiple such answers, we need the largest among them. So that is what I'm checking over here, that if your frequency match, then check the actual number. If your actual number is greater, then take that. That is it. And I'm returning the max. That's it. So yeah, please code this. This actually helps you get accustomed to these practices of modularity. In coding these, where you think there are so many possibilities, how do I include all those possibilities in an easy code? Your code is not that long. This code is, I think, yeah, it's within 48 lines, and this function definition lines are there, class lines, all those are there. Otherwise, it's about 40 lines of main logic, and it looks quite neat. It tells you what each function is doing. So please try coding it from the idea that has been shared. Take care, keep coding. See you in the coming videos.